All right, so it's time to start. Let's jump right into it. Have you experienced other webinars before? Have you attended to another KNX webinar? If yes, how was it? What manufacturer did you listen to? Which products were focused in those webinars? And most importantly, were you satisfied with the webinar? So it would be great if we could already get a little feedback in the chat. Feel free. I would like to do this webinar today as interactive as possible. So whenever you have a question, just shoot, post them in the chat. But let's start for now. So the topic of today's webinar is setting up KNX weather stations perfectly. About the agenda that we will be talking today, you will hear in the following slides. So yes, the webinar today will take place live. So this is not pre-recorded. This is 100% live. So please apologize in advance if anything with the software that we're using today is not working out perfectly. It's our first webinar, but of course we're doing our best and learning for the next webinars, I guess. So yes, I'd like to start to tell you a little bit about myself. My name is Bastian Elsner. Some of you might know me already. I'm responsible for sales and marketing at Elsner Electronic, and I'll be your speaker today. It's my pleasure that we can spend the next hour together. Let's get right into it. So, as starters, what do you think if you see a facade like this? Feel happy to write in chat. To me, the facade on the left side is something I do not like to see because, and most times the facade is actually very beautiful and architects think a lot about how to design this facade, so it can kind of get ruined with too many ACs on the outside. But there's an alternative to at least reduce the ACs, and that is what you see on the right side. It's basically automatic shading control, and that is basically the main topic for today. So after our webinar, you will be able to select the right Elsner weather station. You will be able to select the right Elsner weather station for your project and how to mount it correctly. Also, you will learn how to install the SunTracer Pro weather station correctly. And you will be able to independently implement automated shading with the SunTracer Pro. Okay, so our agenda for today is the following. We separated the webinar today into modules and we will make a quick 5-minute break. In the middle of the webinar, I'll let you know when that's going to happen, of course. So firstly, we will start with the general comparison and the correct installation of a weather station. So we will have a look at other Elsner KNX weather stations and how to mount those weather stations correctly. In the second module, we'll go a bit more detailed into the special features of the SunTracer KNX Pro. We will talk about the set threshold value of wind direction, also have a look at the ETS file. We will also learn how to set the threshold value of a wind alarm and in general how to set a facade automation. So yes, after the first module, you will be able to select the appropriate Elsner weather station for your project and also how to distinguish a good mounting of a weather station and a bad mounting. We will also do some practical exercises, so pay attention. The results will be public. Of course, not for every person, but you will see basically the poll, how everyone answered this question. All right, let's start with the first module. On the left photo, you see the largest version of our KNX weather stations, the SunTracer Pro. This has a facade automation for up to 12 facades. The special feature of the weather station is that it can detect the wind direction. Next up, you will see the SunTracer SL series. This might seem familiar since many of our weather stations have the same housing, but there are some slightly or even bigger differences between the different models. So yes, we have the Suntracer SL, SL Lite, and Basic. We'll talk a little bit more about that on the next slides. On the next picture, you can see the PO4 KNX weather station. This is the smallest version of the KNX weather stations. The device has no facade automation or logic function included. So this device is only able to send measured values to the bus, for example, to a building automation system or to a visualization for temperature, wind speed, etc. On the right side, you see our newest edition of the KNX weather stations. If you follow me here on LinkedIn, you must have seen it in the past weeks because I was talking a lot about it. It's a very recent product and I'm very happy how we started with it. So yes, this is our newest weather station. It is very, very similar to the functionality of the Suntracer SL Lite, but the novelty is that the wind measurement is done by a wind wheel and not electronically. We have this version with the GPS version or without the GPS version, so basically the big one and the small one. All right, so that has already been a lot of input. To help you with the choosing of the weather station that you need for your specific project, we summarized all the information in a handy chart that can be found on our website. So here you basically see all the specifications that a website has, that the weather station has, and also how many facades you can automate with the specific weather station. As said, this table can be found on our website, and if you're interested and want to know where to find it, just shoot a message in the chat and we can send the link. All right, let's go into the more practical part of the webinar, how to mount the different types of weather stations correctly. Let's start with the type SL. So all weather stations with the housing shape of the Suntracer SL, as seen in the photo on the right, are mounted identically. So that means the Suntracer KNX-L, Suntracer KNX SL Lite, SL Basic, and P04 GPS are mounted in the same way. The weather station can be directly mounted to a pole on the roof, for example, with a clamp. Or the other option is that it can be directly mounted on the facade, as you can see on the picture here. It is very important that in order to measure the wind direction and the wind speed correctly, the weather station has to be located on the lee of the facade. Therefore, the installation on the facade only makes sense if shading sits on the same facade. Furthermore, the weather station can be mounted with the help of a boom to set off from the facade. Here you can see the boom. So this is also very important that you have a lot of space below the weather station so the wind measurement can measure correctly, because if there's not at least 60 centimeters below the weather station, the wind sensor can't measure correctly. Sounds pretty easy, but it's actually one of the most common mistakes that we encounter in our service department. All right, let's move on to the mounting of the Suntracer KNX Pro. The Suntracer KNX Pro weather station must be mounted on a mast on the building due to wind direction measurement. Also here you need to have a lot of space around the weather station so it does not get influenced by any parts of the building. A mast extension as well as the suitable mounting material is included in the scope of delivery, so you do not need to buy it extra. It will be within the scope of delivery of the Suntracer KNX Pro. So here you see the assembly with the mast. Here you see how the mast can be assembled, and this is the entire assembly of the Suntracer KNX Pro. So next up, the orientation, which is quite important, how you need to orientate the Suntracer KNX Pro. So the weather station must be orientated so that the base of the device faces north and the ring faces south, as shown here. Here again, just for visualization purposes. All right, we're already entering our first practical exercise. So I will start a quick poll that you can all answer. I hope you all paid attention. So if you did, it should not be any issue to say which of the 3 weather stations is installed correctly. We can have a look for a couple seconds more. And now we start the survey. All right, so we're slowing down with the answers. 78% of all the attendants answered the poll. And yes, the correct answer is model 3. So the picture number 3 was the correctly installed mounted weather station. So as I mentioned before, the weather station needs to be exposed to wind so the sensors can actually measure correctly. So in the first picture, if you can recall, there is not enough space for the weather station to measure correctly. You can see the green roof will hinder the wind measurement. Also, sun sensor is on top of the weather station. So picture 2, there is shade cast on the weather station. So the brightness sensor won't work correctly. Picture 3 is the correct answer, and 41% of you guys got it right, 17 got it wrong, and another 41% got it wrong as well. So thanks for attending this quick little exercise. We're going to do a couple more over the course of the webinar. All right, let's continue. We are already at the end of our first module. So now we can distinguish between the different weather stations, and we know how to mount the weather stations correctly. If there are any questions at this point, please feel free and post them in the chat. We'll take our time on the following days after the webinar and try to answer all the questions that might come up during the webinar. All right, now we start with the module 2. In the following module, we will deal with the Suntracer Pro KNX in detail. After this module, we know all the special features of this weather station. We know the possibilities of limit setting for wind direction and wind alarm, and also the settings of the facade automation. Let's start off by the features of the Suntracer Pro. We'll start off by the sensors. So firstly, we have a temperature sensor. Secondly, we have the measurement through ultrasonic measurement of the wind speed and wind direction. The sensors are situated in the middle of the device, so basically in the middle of the ring. That's also why we have this unique form of a ring. So we have some sort of measurement area in the middle of the weather station. Next up, we have 5 different brightness sensors situated on different parts of the weather station. You can see it on the symbols on the weather station. Why? We have so many to get an as exact measurement as possible. Next up, the precipitation. Also humidity, air pressure, GPS location for location and time, and also for the calculation of the sun position, which is very important for the automated shading control we will be talking about later. Now to the functionality of the Suntracer KNX Pro. We have the automatic function for up to 12 facades. The display of the sensed temperature, the wind measurement wear-free with ultrasound, the output of wind direction in degrees and in text form, as well as the output of air pressure in hectopascal and text form. The KNX programming can be done via a magnetic switch. So in this chapter, we're already at the end of this chapter. It was quite a short one, but in this chapter, we learned more about the special features and of the sensor technology of the Suntracer KNX Pro. Next up, we will go into more detail about setting the wind direction and the wind limits. So firstly, the wind direction must be integrated into the facade via an input object, which is the safety object. So the setting of the wind direction limit is not integrated in the facade and must therefore be parameterized separately. If the wind direction is to be integrated in the facade automation, this is done via an input object, the safety object. Here, the wind direction threshold value is applied. The output object 1-bit is linked to the input object safety. So this is the first general information, very important for the ETS screenshots that we'll have a look at in the next couple minutes. All right, now we would like to look at the settings of the wind direction limits. So here you can see the parameter settings. You can set whether the values received via a communication object are to be retained after voltage recovery, plus reprogramming, or loss setting. We set the setting to not. Here in this green box, we can set the angle range. The range specification can be specified via the parameters, fixed values in the application, or via communications objects, for example, for a visualization server. Here in this green box, we can have the settings for the hysteresis. So the hysteresis must be set. The hysteresis is basically the switching point between range exceeded and no longer exceeded. In the next setting area, we can set the delay time from 0 to 1 and from 1 to 0. Here we recommend always to set a delay, for example, from 0 to 1, which equals 2 seconds, or from 1 to 0, which equals 5 minutes. So this causes that the wind direction must be fulfilled for 2 seconds that a 1 is sent on the bus. If the wind direction is no longer fulfilled for 5 minutes, a 0 is sent to the bus again. This is very important because you do not want to have your shading extend and retract if there's just a slight change in the wind direction or wind speed. That's why this delay time is very important, because you don't want your customer to have your shading move all the time. You want to have it only if there's a significant change over a certain set amount of time, and this certain amount of time can be set in this option here in the ETS. Lastly, we have the output of the threshold value can be deactivated, blocked via a blocking object if desired. We set it here to no. If you want to block it, yes, of course. Okay, next up, we'll have a look at the wind threshold value. So setting the wind threshold values. The settings of the wind force depends on the curtain used and the design or positioning on the object. The maximum wind value must be therefore requested from the shading manufacturer. We have already discussed the first point. The threshold values received via the communication object should be retained, in the case of the wind direction threshold value. The wind threshold value can be specified via the parameters, fixed values in the application, or via a communication object, for example, for a visualization. In the next step, a hysteresis In the next step, hysteresis must be set. The hysteresis can be set in percentage or as an absolute value. The hysteresis is the switching threshold between the wind value exceeded and undershot. Let me give you an example. So in our example, we have set 4 meter per second as wind threshold value. If the value of 4 meters per second is exceeded, the alarm 1 is sent to the bus. If the wind value falls below 4 meters per second or between 2 meters per second hysteresis, the alarm is deactivated and a 0 is sent to the bus. In the setting of the switching output, we can set how the switching output should work when the threshold value is exceeded. This means that we can select, for example, whether a 1 or a 0 is sent when the limit is exceeded. In addition, a switching delay can be set. A switch on delay 0 to 1 is recommended so that, for example, wind gusts are faded out, and switch off delay 1 to 0 so that only with longer calm is extended again. More about this later. So here another example that the fading out is up to you, that you can send it in the set the parameters correctly in the ETS. This is very important because once again, just because there's a slight difference in the wind speed, you do not want your whole facade automation to move. You want to have it for a longer period of time to really say, okay, there's a longer calm without any danger. I can put the blinds down again. So you should not be thinking about it. Your building, your project should be thinking about it. That's why you have a very smart weather station. Okay. Next up. In the first step, we specify whether to enable the lock with the value 1 or 0. In the second step, the value of the lock is defined before a communication object is sent, whether the lock is active or inactive after reprogramming. And in the last setting, we can specify if we want to send a certain value when locking, for example, lock active, wind alarm. So on this slide, we have a small visualization of what I just have said before. Since it's very theoretically, we try to give you this visualization as an orientation to understand what I said before a little bit better. So we have just dealt with the detailed settings of the wind alarm. Now I would like to show you exactly this again briefly in a diagram. For explanation, the blue line shows the wind speed. So the yellow line is our set wind threshold value, and the yellow dashed line is our hysteresis. So only if the wind speed is below or above the set hysteresis, anything will happen, because in between, you do not want your facade to move if there's just a slight change. You need to have this over time in order to get an action from your facade automation. Okay, now we move on to setting the wind threshold in the facade control system. Here you can set the wind alarm, and if desired, wind extension locks are determined. So here we have the ETS menu. In my example, I use the wind alarm by threshold value. Since I use the wind value measured by the weather station, I have selected the measured value from the internal sensor. If there are individual wind sensors on the building, for example for the facades, these can be integrated via a communication object. For this, the setting measured value from internal sensor would be set to no. For this, the measured value of facade 1 wind is activated. The following object then receives the measured wind value from the external individual sensor of the facade. A maximum of 12 individual sensors can be integrated. In the right window, we can still see the setting of the wind threshold value as on the slides before. All right, now we are basically in the middle of our webinar, so half is done already. I propose to make a quick 5-minute break. I'll be back in 5 minutes to continue the webinar. If you have any questions in the meantime, feel free to post them in the chat. Thank you for your attention so far, and see you in 5 minutes. So next up, we will talk about the facade automation. First of all, we will go into the functions of facade automation. So now I would like to introduce briefly the individual functions of the facade control system. Firstly, we start off by the timers, which is basically used for time opening or time closing. Next up, we have the night closing functionality, the heat protection, a pyranometer, a rain automatic, an indoor temperature block, and automatic sun protection. But we will deal with this in way more detail in the following slides. And lastly, we have the outdoor temperature block. Later, we will deal with a separate section with the protection functions for the facade. We have the wind speed, frost, and rain. Okay, next we're going to talk about the classification of the facades. A quick hint, we will gonna do another survey in around about 1.5 minutes once we finish those slides, so I recommend paying attention if you would like to get the next one right. Okay, here we have a very standard building. We have 4 facades. For the shading automation, it's very important that you define the individual facades of a building. If you would like to show the classification of the facades by means of some example, which can be used for most building types. So we do not have all building types, of course, this is impossible, but the most common that we encountered in our 30 years of experience will be displayed on the following slides. So in the first photo, we have a very basic one with 4 facades. In the second photo, you see another building shape, which is the U-shape floor plan, and that one only has 4 facades as well. Remember that one. So you can see that the 4 will be here twice, same as the 3, you will have 3 times, the 2 times, and the facade 1 remains the only facade. So you can control those in groups since they have the same orientation. Next up, it gets a little bit more tricky, I would say. So for buildings with an asymmetrical floor plan, the division of the facades is somewhat different. The facades with non-rectangular orientation, so number 2, 3, and 5, and the setback facade 6 must be controlled separately. The division can be seen in the floor plan shown. Curved round fronts should be divided into several facade segments to be controlled separately. So I wait a couple minutes so you can have a closer look at the floor plan that is displayed right now. Okay, as mentioned before, the next practical exercise. So how many facades does this floor plan have? I give you a couple seconds and then I'll start the poll. All right, let's start with the poll. All right, that is looking pretty good. For now, 80% got the right answer. Okay, the answers are slowing down now, so I believe everyone that wanted to answer this poll did it already. Of course, the right answer is for facades, and 67% of you got it right, and the remaining participants got it wrong, and 73% of all participants took part in the poll. Thank you for that. Okay, next up, a little bit more complex topic. It's the alignment of the facade. For the facade automation, we need to define the alignment of the facade. The facade alignment corresponds to the angle between north-south axis and the perpendicular to the facade. North stands for 0 degrees. The angle alpha is measured here in a clockwise direction. In the example, the angle are here marked in red is rotated by 30 degrees to the north. Thus, the alignment for the facade corresponds to 1 equals 30 degrees. The other angles result from the alpha angle plus 90. You can see it in the figure. So as a result, the facade alignment is as follows. Facade 1 has the alpha angle. Facade 2 has the alpha plus 90 degrees. Facade 3 has the alpha plus 180. And facade 4 has the alpha plus 270 degrees. Next up, we're going to talk about the angle of inclination of the facade. So in the picture, in this one, you can see a facade with an inclination. If a facade surface is not aligned vertically, this must be taken into account. An inclination of the facade to the front is counted as a positive angle. An inclination to the rear, as seen in the displayed figure, is seen as a negative angle. If there's no inclination, the value is 0. Here, the adjustment of the inclination is to be made. This is the extract from the ETS file, and as said, here you can do the adjustment of the inclination that can be made. All right, next up we have the sun direction, which is named azimut in the ETS files. So the position of the sun indicates the area of sunlight on the facade, depending on the surrounding conditions. The area must be adjusted. So of course, every house is individual, or every surrounding of the house is individual. The sun range is often already restricted by neighboring buildings or planting. Like in this example here, the green dots symbolize trees, and the sun, of course, the sun, and the little square with the 1 on top should symbolize the corresponding building. As you can see, natural shading exists from the trees. This is visualized here. So that needs to be taken account into a sort of high-level building automation and shading control. Only when the sun moves during the course of the day, you can see it here in the second figure, it does hit the building unhindered. Before, there will be shade cast naturally by the trees. And this is exactly where the shading of the blinds is required. Not before and not after, only when the sun is hitting. So in this, to achieve this effect, to only use the blinds when they are actually needed, you need to set the parameters azimut in the ETS application. So for this setting, we offer fixed areas, for example, south, east, west, and also combinations. An individual adjustment of the range is also possible, of course. For this, the angle range is activated. Now, The individual sun ranges can be entered in degrees. Next up, we'll talk about the sun height, or also called elevation. And the next point, we consider the height of the sun. So in our example photo, the facade is shaded by the projecting roof when the sun is high. Only when the sun is low, approximately 53 degrees below the roof, shading is necessary. Before you have it's not a natural cast, but the cast of the shadow from the building shape. So the values entered in this green box here help you to set the parameters right. So basically the shadow edge, you can see in this photo, it's around about 53 degrees to only extract the shading once the sun surpasses this point. Next up, we will talk about the brightness. As you probably remember, we have 5 brightness sensors in the Suntracer Pro. So we can select whether we use the internal sensor or an external sensor system of another transmitter for the threshold value. Then we can set a threshold value for brightness, for example, 60 kilolux. For falling below the threshold value, a hysteresis in percent or kilolux can be selected. In addition, there are corresponding delay times for brightness control. For example, extension delay, short retraction delay, and retraction delay in general. Let me give you an example. So if the brightness limit value 60 kilolux is exceeded for 1 minute, the shading extends, because then there's so much sun coming into the building and you want the shading to extend. If there's a short cloud after the extension, so the short delay of 60 kilolux is interrupted, you do not want your want the entire blinds to move up. So that's why you can set the short delay, which is interrupted, for example, 10 seconds by a huge cloud. The slats can be opened to get the daylight in the room again. If the threshold value is undershot for 30 minutes though, the shading is retracted again. So as I explained in other examples, if you're thinking about the automatic shading control, you do not want to have your movement like any minute if there's a slight change. You only want to have it if there's a significant change over a specific period of time that you can set in the ETS settings as displayed before. Next up, we talk about the slat and shadow edge tracking. In the facade automation, you must select which shading function is desired. Here you can see the following options. Without tracking. There are the options without threading. Shading goes down in the sun and opens the slats to a fixed value. Next, slats in 4 steps. The slats will track the sun in 4 predefined values. Next, slat tracking. The slats move automatically with the height of the sun. Shadow edge tracking means that the shading changes the driving position independently and adjusts it to the shadow edge. So the shadow edge tracking and slat tracking. The slat automatically tracks the height of the sun. The shading changes the driving position independently and adjusts it to the shadow edge. Here we do have some visualizations for what we just discussed. So the sunshade for high sun. The sunshade is only partially closed and automatically lowered, only so far that the sun cannot shine further into the room than specified above the maximum permitted penetration depth. Next up, on the next picture, we can see the sunshade for a medium position of the sun. The sunshade is automatically lowered only so far that the sun does not exceed the maximum permitted penetration depth in the room. In the last picture, you can see sunshade for a low sun position. So the sunshade is automatically lowered almost completely, so the sun does not shine too far into the room to prevent overheating from too much sun exposure of the glass. And so you also do not need to use that many air conditioners as in the introductory picture. So yes, I'll give you a couple seconds to read the information and to have a look at the 3 different positionings that can be set due to the use of the weather station and the parameterization in the ETS. Okay, now we will go in the detail settings of the sled. So now it's gonna get a little bit more technical since this is gonna be, yeah, very detailed, I'd say. So first of all, it is very important that you define what type of sleds you have, if you even have any. So both horizontal and vertical blinds can be used for shading the facades. Both types of shading can be controlled so that no direct sunlight shines into the room. In order for the shades to be controlled correctly, the distance and depth of the sleds must be known. For this purpose, the width and the distance between the sleds are measured. These values must be entered correctly in the parameter settings, which can be shown here. So let's go into a bit more detail of the horizontal sleds. The possible angle at sled position 0 depends on the mechanics of the shutter and the actuator. Shades do not fold inward, are shown in the picture on the left. In the first picture, we see an angle of 90 degrees with a sled position of 0%. In the second picture, we see an angle of 10% with a sled position of 100%. Shades that fold inwards can be seen in that picture above right. Here, the angle is, for example, 160 degree at 100% sled positioning. The angles must be measured out, for example, with a set square or requested from the shading manufacturer. The determined values are then entered in the parameters. Here you can see the parameters. Okay, next we will talk a little bit about the sled positioning for vertical sleds. The possible angle at sled position 0 depends on the mechanics of the shutter and the actuator again. Shades do not fold inward are shown in the picture on the left. Shades that fold inwards can be seen above right. The angle is, for example, 130 degrees at 0% sled position. Here we have a look at the parameters. This must be measured as well with a set square, or also you need to request the information from the shading manufacturer. The determined value are then entered in the parameters. You can see right below. The facade protection is very important to set. Earlier we discussed the wind alarm settings. Remember? The facade automations offers further protective functions. So we have for cold regions, we have the frost alarm. If the outdoor temperature falls below 2 degrees during or up to 5 hours after precipitation, the frost alarm is activated and the shading is retracted. Next up, we have the rain alarm. In addition, a rain alarm can be activated for fabric shades. This moves the drives to save the position in event of the rain. Next, we have the rain automatic. The automatic rain function causes the blinds to extend when it rains so that they are washed and cleaned by the rain. I really like this function because it saves you a lot of cleaning costs over the course of the year. Let's talk about the active facade status objects. So the sun tracer includes a status output object of the facades via communication objects. Here you can see the parameter and the objects. Via the status output X, the status messages of all facades can be viewed with plus. You can scroll the individual facades to query the status output. The same objects exist as an individual status message for each facade. These are called facade 1, channel status output. Those ones. Okay, now we're going to do another little exercise. It's the last one. So what alarms for facade automation have we learned about? What did we discuss in the last couple of minutes? I'm going to start the poll now. That's a tricky one. All right, so the answers are slowing down again. As said, this is a tricky one. So only 22% of you guys got it right. The right answer is A. Rain, frost, wind, and heat alarm. We discussed this a couple minutes ago. Okay. So we arrived at the end of the second module, and I'd like to give you a small summary. So in the previous chapter, we dealt with the settings of the sunshade automation. For this purpose, we dealt with the definition and the alignment of the facades. Then we got to know the shadow edges and sled tracking, as well as the sled distances and angles. At the end of the chapter, we got to know the alarm functions and the status output of the automatic facade control. Now, we still have a little bit more time, and I'd like to do an open Q&A session. So once again, please use the chat functionality and ask whatever questions that might came up during the webinar or even now. Since this was our first webinar, but we're planning on doing them more regularly, we wish to improve because I'm well aware this is the first one. It was not perfect, but we want to get better for the future webinars. So now is the time to tell me your wishes. What would you like to see for the next webinar? Also, what suggestions do you have? So what can we do better? What was good? What was bad? What you didn't like? Was it too long? Was it too short? And most importantly, what would you like to see in future webinars? We felt like that our weather stations are a good place to start since they are rather complex to integrate because it's a complex functionality that can be done with a weather station, but it also boosts the value of a proper building automation project by a lot. So yes, we have some other products that are very easy and you could go over them in a couple of minutes, but it's up to you. Please let me know what products you would like to see in future webinars as well. What did you like? What you did not like in this webinar? And yes, feel free to use the chat function. Also, here are my contact details. So if I can help you with anything else related to Elsen Electronic, feel free to send me an email, find me on LinkedIn, give me a call. My number is in the email signature. So happy to get in touch and help you out with whatever you might need. Then from my end, that's it. Thank you very much for attending our first webinar. It was a pleasure being your host and your speaker today, and I hope to see you in the next ones. So take care and have a great rest of the week and an awesome weekend ahead. Bye bye.